Alright, so this is going to be a real quick video. I just figured that a few of you might have a little bit of trouble with this problem that I put up on the homework. This is the last problem. It's number 16. So you might get lucky enough that you have the exact same letters as I do. But if not, just follow along and your problem should be very similar. Okay, so remember our objective for this section is not to solve the different equations for numbers, but to actually isolate one of the variables and get it by itself. So we want to solve for b. You see you got a b here and a b here, and this one presents a bigger problem because it's part of a fraction. So what we want to do first is let's simplify this fraction a little bit by, we have a fraction here times this variable f, okay? And we can think of f as a fraction. This is getting a little bit crowded right here, so let's clear that up. We can think about this f as a fraction as well as f over 1. So if I'm going to have something over something, and let's make this two things to keep this nice and easy, times something else, right? We have to distribute across the fraction. So what we're going to actually have to do is take b minus p times f over j, and then f is over 1, so we can just ignore that right there. And we're just going to distribute the b and the p to the f. So my new expression now becomes y is equal to b minus, let's deal with that minus in a second, bf minus pf over j. Okay? Now, let's distribute that minus across this expression to give me b minus bf plus pf all over j. All right, now we can start dealing y. Now we can start dealing with the rest of this problem. So the first thing I want to do is subtract b from both sides. So I get y minus b is going to be equal to negative bf plus pf over j. And as long as I remember my objective is to get the b by itself. All right, well, this one is I got the b over here, that's good. I have a b over here, which is not so good, so I want to isolate that. So in order to do that, let me multiply everything by j to get rid of this fraction. It's always better to get rid of fractions if you can. Again, I have to distribute jy minus bj is equal to negative bf plus pf. Okay, gonna need a little more room. Now, because I want b by itself, I need everything with a b on the left side and everything without a b on the right side. So what I'm going to do is I'm going to add bf to both sides to give me jy plus bf minus, whoops, it's a little ugly, minus bj. These two cancel, is equal to pf. And I'm going to subtract jy from both sides because it doesn't have a b in it. Okay? So now when I look at this expression, I have bf minus bj is equal to pf minus jy. And that's nice because now I have all my b's on the same side. And to put them together, I'm going to use the distributive property backwards, and that's called factoring. So I'm going to factor out the b to be left with f minus j is equal to pf minus jy. And the last step, because this is multiplication, is I'm going to divide out the f minus the j. Now this expression that's left over might not be pretty, but bf minus jy over f minus j. Doesn't matter what it looks like, we accomplished our objective. I have isolated the b. I have b by itself. Okay? So, to recap, let me go all the way back up. So to recap, we distribute, we get this expression, distribute the negative, okay? This one's going to turn into a positive because I'm going to time negative times a negative turns into a positive. Move this front b over to this side, clear the fractions by multiplying by j. Get everything with a b to the left-hand side. Sorry about that. Everything with a b to the left-hand side. Everything without a b to the right-hand side. Factor out the b, and then divide out the expression that's left over. The steps should be fairly similar, and if you follow that, you should be able to get this question right.